Hey everyone, Forging Station here, and today we are going to rotate a cube but without using classes to do it. We are only going to use structs, and this is going to be the most overkill way to rotate a cube. Dots relies on structs, the orderly arrangement of data in your memory, which will eventually be read into CPU cache, promoting SIMD operations, which is highly parallel and blazing fast. The idea of using struct-based system is interesting because of this very reason, which means no managed references. Best of all, you can burst the main thread as well. I will leave a few good reads in the description down below. This might as well be the future of game logic programming, or at least a step in the right direction. That is perfect dots based approach for game logic. As always, this is just one way to do it, and it is meant to be a proof of concept to get your creative juice oozing down your ears. First, we are going to have a cube and apply some material onto it. We are going to attach an authoring component called cube component data, which specifies the speed at which the cube should rotate. This of course is optional, as you can add it via code, but I won't create a tangent here, and as I said, it is just one way to do it. We will need another authoring component called cube spawner component data, holding the prefab itself, which will be spawned. Let's create a new game object, attach the convert to entity script, and attach the cube spawner component data. If we now hit play and see the entity debugger, we will see our cube entity with cube component data because we attached it and it exists as a prefab. We cannot see it on screen because we have not instantiated the entity yet. We just converted the cube prefab into entity, and that is all. Now let's create a cube system to spawn the cube entity and rotate the cube. Since we are only going to use structs, we will implement iSystemBase, which has familiar looking create, update and destroy method that have a state argument. The state is also a struct of type systemState, which keeps track of raw entity data. This means it can keep track of changes done to entities by other systems, like disabling an entity, for example. This is a very bad explanation, and I'll have a link in the description down below if you want to know more. We are going to need two jobs, one to spawn the cube and the other to rotate the cube. I will use the iJob entity batch way of writing these jobs. The spawn job is going to need a command buffer to queue up the spawn or instantiate calls, as well as the cube spawner component type handle to get a reference to the prefab that has to be instantiated. Again, it is not necessary to use parallel command buffer as we are only spawning one cube, but now you know how to do it in case you want to spawn multiple entities. One thing to note here is that index that we need to supply to the instantiate call during parallel execution is the entity index and not the batch index. The other job that we need is the rotate cube, which is straightforward. This time we will need the cube component data attached to instantiated entity to get the speed at which the cube should rotate. We can now update the rotation of the cube based on this value. You can watch my previous video to know more about the iJob entity batch and how it compares to entities.forEach loop. Now we have to schedule these jobs in the right order in the update method. To prevent unlimited spawning, I am simply going to have an int variable, note it is a value type, to control the number of cubes to spawn, which in our case is just 1. This gives me finer control over the spawned entities. The problem I had while spawning entities in my dots navmesh video, trying to control the number of spawned entities outside mono behaviors. We also have to refer the world via state to create the command buffer. Since we are using get or create command buffer, we are going to refer the same command buffer that we can submit to the job and read back to see if there are any calls to spawn. If so, we will spawn all the entities at once during the sync point. Note that the this keyword cannot be used to tie up dependencies here. Instead, we can get the dependencies using, you guessed it, the state. We can finally schedule the rotate job with a read-only type of cube component type handle, as we are only reading the speed at which the cube must rotate. Last but not least, burst the main thread, the update method, and of course this has to be a struct, not a class, which I always forget. With all that done, if we specify the speed in prefab and hit play, we will see the cube rotating. So there you have it, a way to instantiate an entity and operate on entity without using a class. Of course, this is overkill and there are lot many things you can do here, and constraints only make you more creative. Let me know if you want me to create new systems this way and convert any other system I have built using structs. This is all I have for now, guys. Thank you for watching and I'll see you in the next video. Have fun.